Very much. Welcome back. It's now my pleasure to welcome our second panel of witnesses from Polar Environment Atmospheric Research Laboratory, Dr. Kimberly Strong, Professor of Physics at the University of Toronto. From Polar Knowledge Canada, Andrew Applejohn, Executive Director of Programs, and Dr. David Hick, Chief Scientist. So we give you up to 5 minutes for opening remarks, after which we'll proceed with rounds of questions. Dr. Strong, I invite you to make an opening statement of up to 5 minutes.
Thank you. I thank the committee for undertaking this study and for inviting me to speak to you about science and research needs in Canada's Arctic. My name is Kimberly Strong. I'm a professor and the chair of the Department of Physics at the University of Toronto. I'm also an atmospheric scientist and the principal investigator of PEARL, the Polar Environment Atmospheric Research Laboratory. My group has been doing research at this location for 25 years. I'm speaking on behalf of the PEARL Science team, which includes colleagues from 9 universities. We also have many partners across Canada and internationally, and work closely with Environment and Climate Change Canada and the Canadian Space Agency. Work at PEARL is conducted under a scientific research license from the Nunavut Research Institute. The Arctic remains one of the Earth's least understood environments, and yet it is a bellwether for climate change, a receptor for global pollution, and a driver for the global climate system. Northern ecosystems, including ice, snow, and permafrost, wildlife and vegetation, and marine systems, are all linked together by our atmosphere. It contains the air we breathe and the protective ozone layer. It stores greenhouse gases. It's where weather happens, and it transports air pollution and wildfire smoke into the Arctic. PEARL is a flagship observatory established in 2005 to track changes happening in the Arctic atmosphere and for determining the causes and global impacts. PEARL is located at 80 degrees north on Ellesmere Island, near the Environment and Climate Change Canada weather station at Eureka, Nunavut. For nearly 20 years, PEARL measurements have provided insight into an array of scientific, policy, and societal issues that are relevant to Arctic communities, Canada, and the world. PEARL's focus on long-term atmospheric measurements in the very high Arctic differentiates it from the research activities of the Canadian Arctic Research Station at Cambridge Bay, from ArcticNet, from the Centre for Northern Studies, and the Amundsen Icebreaker. We're all complementary in what we do. PEARL is an important Canadian station in 5 international observing networks. As the most northerly permanent station for most of these networks, and one of only a few in the Arctic, PEARL measurements fill a very large gap in their geographical coverage. PEARL is also a key site for verifying the data from satellite missions, including the upcoming High-Altitude Aerosols, Water Vapor, and Clouds mission, which will be Canada's contribution to NASA's multi-decadal atmosphere observing system. PEARL offers exceptional educational opportunities and has trained more than 100 students, postdoctoral fellows, and technical staff, most of whom are now working in government, academia, and industry. Our outreach program has been active in 6 northern Nunavut communities through school visits, student researcher collaborations, and workshops for teachers. PEARL is remote and isolated, accessible only by charter aircraft and the annual summer ship visit. The nearest community, Grise Fjord, is more than 400 kilometers to the south by air. PEARL is thus very different from a normal campus-based lab or facility located in a community. The December 2023 report of the expert panel on the future of Arctic and Northern research in Canada highlighted PEARL as a unique and internationally important research facility. The report stated that even where infrastructure is remote and where there are no nearby communities with which to partner, facilities such as PEARL represent critical elements of an effective research system and cannot go overlooked. Over the last 18 years, Canada has invested in PEARL infrastructure, operations, science, and training. However, this investment is now at risk. PEARL needs stable funding that's attuned to being in a unique facility in a unique location. Unfortunately, PEARL does not fit easily into any of Canada's major recurring funding programs. Many of the programs that previously supported PEARL no longer exist, and PEARL's last major grant ended in 2021. PEARL is currently running at a minimal level and will close this year if new funding is not secured soon. Let me summarize my remarks with reference to the 3 points being assessed by the committee's study. Number 1, to understand the consequences and impacts of environmental change, we need to track changes over time. We need a long-term strategy for supporting Arctic research in Canada, a strategy that's inclusive of different approaches, including both Indigenous and Western science, a strategy that encompasses the many different components of the Arctic ecosystem, including the atmosphere, which sometimes gets left out, and a strategy that engages and reflects the needs of local, regional, territorial, national, and international partners. Number 2, to fully participate in research, Arctic and Northern populations need access to infrastructure tools and funds. This is true of Arctic research in Canada generally. PEARL is just one example of a facility that's under pressure due to the lack of continuity and sustained operational funding. Establishing research capacity is a huge effort with long lead times. Losing that capacity can happen all too easily. We need sustained funding programs that recognize that research in the Arctic is challenging and expensive, and it should not have a one-size-fits-all model. It should recognize that not all Arctic research is conducted in communities. And finally, number 3, collaboration with local and Indigenous communities is vitally important. However, factors like distance, travel costs, and the effort involved in establishing and then sustaining those partnerships presents barriers to meaningful collaboration. This is even more difficult for facilities like PEARL, which don't have the advantage of being located near a community. We need mechanisms to bring together researchers and community members to build cooperative partnerships for long-term and sustainable Arctic research. Thank you again for this opportunity to address the committee.
Thank you. Just bang on the time. You crammed a lot of useful information in your 5 minutes. We appreciate. So, okay, we'll now turn to MP Longfield for 6 minutes.
Our witnesses. I want to start with Dr. Strong. I was able to get up to PEARL in 2019. I saw the research going there and the number of universities that are involved. University of Toronto being the lead of 9, I think you mentioned. It seems like PEARL has gone from NSERC grant to NSERC grant and is doing longitudinal studies that are giving us changes over time in the atmosphere, now picking up on forest fire implications, looking at droughts and floods and atmospheric conditions that are changing in terms of moisture in the atmosphere. Really important work that seems to be reliant on short-term funding from fund to fund, and now you're in a precarious situation. What's your current ask to try to keep the doors open?
Right, thank you, Mr. Longfield. So our current ask right now, our submission to the pre-budget consultations was $15 million over 6 years. So that's about $2.5 million a year to do the science and also to give us the funding to be able to resume the program that we had in working with some Nunavut communities. $1.5 million a year would kind of keep us going at a baseline level, but 2.5 is really what we had some years ago, and that's really what we would like to do to be able to allow us to do all the science plus more than science with northern communities.
In terms of the science research, there's new funds now going into the Arctic in other parts, and maybe Dr. Hick, in terms of your organization, involvement with an organization like PEARL, is there a communication path there, or is there opportunity there? I'm not asking you to approve funding at the table, but that doesn't seem like a lot of funding to do some very important research in Canada.
Well, I've worked with Dr. Strong for many years, and so we have good lines of communication. We're certainly aware of the valuable work that's been conducted at PEARL over the last couple of decades. And in fact, we're working together to, the Arctic's a big place, so we're working to expand some of the capabilities, observational capabilities that exist at PEARL at CHARS, at the High Arctic Research Station. That'll give us just a better understanding of the dynamics of the whole Arctic system. So in that context, we're supporting the research work, but the work at PEARL itself, as Dr. Strong indicated, given how remote it is, has additional requirements over and above how remote we feel in Cambridge Bay, just that much further into the Canadian High Arctic to maintain those operations.
I think you've highlighted one of the challenges, that PEARL is quite far north of any population base. The Inuit don't go that far north. Certainly not a lot of voters in that part of the territory. In terms of governance for PEARL, maybe Dr. Strong, how the University of Toronto has taken the lead and really kept the organization going over the last year where there's been a funding gap. But the University of Toronto doesn't qualify to support all of the universities up there in terms of governance. Could you maybe talk about Arctic research having to be a collaboration of governance, or how can we look at our study to support the collaborations that are required to do effective research?
So with PEARL, we really got started back in 2003, 4, 5 when we got funding from the Canada Foundation for Innovation. So that allowed us to install the equipment at existing Environment and Climate Change Canada building, and then bring up some containers and set up 2 other facilities. So we have 3 facilities at Eureka. So it was CFI that really enabled that at the beginning. And then we got 6 years of funding from the Canada Foundation for Climate and Atmospheric Sciences, which no longer exists. So that gave us stable funding for 6 years that enabled us to do, keep operations going and do the science. Then there was a gap for about a year or so, and then we were very fortunate to get funding under the NSERC Climate Change and Atmospheric Research Program, or CCAR, which was a one-off. There were 7 lucky winners, and we got funding from that, which we were able to stretch out to 2001 because of the COVID pandemic. Our expenses went down. We weren't able to travel up so far. We also got funding from the International Polar Year in 2007 and 8, and some funding from the Arctic Research Infrastructure Fund. So those were kind of 5 of the big funding programs, several of which don't exist. CIFCAS, right, CCAR, IPY, they don't exist anymore. And so we also have gotten funding, regular funding from the Canadian Space Agency because we do validation of satellite data, and they've been a very valuable funding partner. And Environment and Climate Change Canada, also because we're working at their facility, they help with some of the power costs, which is not an eligible expense under NSERC and other programs. So, over the last 20 years, we've written many, many proposals. They have not all been successful, but, enough have been. And so the challenge is that every funding program has its own requirements. And, those that require you to have community engagement, it's very hard to do that where we are. Our expenses are high. We try to piggyback on Environment and Climate Change Canada's monthly produce charters that bring food up to the station. But if we typically charter our own flights a couple times a year, they're more than $50,000 a pop, right? And then to have someone on site staying at the station, which is the only place, there's no community there, right? There's just the weather station. That's over $450 a day, right, for food and accommodation. So you send up half a dozen students for a few weeks, the costs add up, right? So having a programs that kind of recognize the cost of being in such a remote location are really quite critical.
Thank you.
Thank you so much. MP Cannings for 6 minutes. Thank you.
Thank you, and thank you all for being here today. I'm going to start with Dr. Hick, if only because we kind of go way back to the research that Dr. Hick started on the tundra ecosystems in the southwestern Yukon, and has continued that line until his very new job in the last couple of years. But when we talk about, this study is about research in the Arctic, especially with regards to climate change, and the urgency there is because climate change is impacting the Arctic at a much greater speed than it is us in temperate or tropical latitudes. And you mentioned things like ice extent, permafrost. Some of the most important research, and it may not be the sexiest, is those long-term monitoring data sets that tackle those questions. How can we fix something that we don't know about? And I'll ask Dr. Strong about this as well, but can you talk about the importance of long-term data sets, 10, 20, 30 or more years, and how, they are priceless when it comes to understanding our world. I'm just wondering if you could comment on that.
Yeah, thank you, Chair. That's a very important question, because I think that's at the heart of being able to develop adaptation, mitigation responses, is knowing what's changing. How quickly is it changing? Is it a cycle, or is it just a perturbation, or is it really a long-term directional change? And for that, we do need longer-term records. We have many of those records in Canada. Maintaining them in the long term is a challenge. A lot of people are committed to maintaining those records. But we're realizing that historically we have observations in certain places that may not be where the largest changes are taking place, or where the impacts of current changes are being observed. And those places are in remote places like PEARL, or in the Northwest Passage, where accessing and maintaining marine buoy observations is something that can be done only during a very short window during the season, the open water season. All of these things we're realizing are complemented by the local and community and Indigenous knowledge that lets us extend our understanding of changes much further back in time. So when we talk about scientific observations, perhaps only over 20 years, once we start understanding how people who have lived in those places have observed that environment over generations, it puts things into a better context for us and allows us to better forecast what might happen in the near future.
And Dr. Strong, at PEARL, you have a 20-year data set, and it sort of breaks my heart to hear that PEARL is facing closure. I just think, oh, another long-term data set under fire. I'm just wondering if you could comment on the importance of this kind of work.
So I certainly, agree with what David said. Long-term measurements are really the lifeblood of understanding what's happening in the Arctic. With the long-term data sets that we've recorded, I started doing measurements in spring of 1999, so this is the 25th anniversary of measurements of ozone and some gases involved in ozone depletion. And as a result of that record, we were able to see from year to year there's a lot of variability in stratospheric ozone, which protects us from harmful UV. And so the years where we had very low ozone in 2011, 2020, that really was there visible in the record because we had the long-term baseline. Similarly, with wildfire smoke, we're also measuring wildfire smoke. We see plumes coming up over Eureka. And for example, the fires in the Pacific Northwest and BC in August of 2017 injected record amounts of a number of different pollutants into the atmosphere, and they came right over PEARL, and we had these big spikes. And again, they were very obvious compared to the baseline that we'd collected over years. Same thing with the aerosols and clouds and other things that we're measuring. Because of COVID, which limited our access to PEARL, we now have and then funding, we now have gaps in some of our data records because some of the instruments, they need maintenance, but we no longer have an operator on site year-round. And so you can't go back, right? So the measurements that we didn't get after March 2020 for some of our instruments, we're never going to go back and get those, right? So we've got some instruments still running, some are automated, some we have remote control for. We have some campaigns to go up and do things, but we used to have an on-site operator year-round who would deal with issues, minor issues, but right now we're not able to do that. So we sadly have gaps, and we'd like to ramp back up to where we were.
How much?
To be done. Dr. Strong, what technological advancements have been most impactful in your atmospheric research, particularly in remote sensing techniques? Are there emerging technologies that you believe will significantly enhance our ability to monitor and understand the Arctic atmosphere?
That's a good question. So one of the things that PEARL is quite useful as a site for testing instruments, particularly under really harsh conditions. We have, for example, been testing solar panels for a Canadian solar panel company, and they're very interested to see how well they perform, and then perhaps we'll deploy them elsewhere in northern Canada. One thing that we helped do was to evaluate the performance of an infrared instrument that is going to be deployed on Canada's HAWK mission that I mentioned earlier. This is Canada's contribution to the Atmosphere Observing System that NASA will be launching later this decade. And so LR Tech and ABB, they developed this technology, and we had it at Eureka. We had it side by side with an instrument that's been there, a longer term. Did side by side measurements to evaluate the performance of that instrument and prove that it would be able to do the kind of cloud measurements that we want to do from space. And so that's been very useful. And that instrument is now being actively developed for deployment on a satellite later this decade.
Strong, that is a bit over our time. So now MP Chen for 5 minutes.
Thank you, Madam Chair, and thank you to the witnesses. My question to Dr. Strong is that you've mentioned today in your testimony that PEARL is running out of money. And it's a bit heartbreaking to hear because PEARL plays such an important role in bringing researchers together in an important facility that is widely regarded as important and crucial to produce knowledge around climate change, the atmosphere, pollutants, and how they interact with the environment. In terms of funding, I know you've had moments in the past in your history since being formed in 2005 where you have been challenged with financially challenged. And so my question to you is twofold. One is, can you shed some light in terms of helping us understand how you have been funded? And secondly, what does sustainable long-term funding look like?
To my earlier answer, so the initial equipment was bought with CFI funding, and then we had this six-year project grant from the Canada Foundation for Climate and Atmospheric Sciences, which is an organization that no longer exists. Then we had a 6-year grant from the Climate Change and Atmospheric Research Program at NSERC, which was kind of a follow-on from CIFCUS, and that program no longer exists. Those were our two, kind of primary science funding programs. And then, as I mentioned, we had some funding from International Polar Year, from the Arctic Research Infrastructure Fund. We've kind of had regular small amounts of money from the Canadian Space Agency that have helped, and some support from Environment and Climate Change Canada. And then also, we've had funding from NSERC, for example, for an NSERC Create training program in Arctic atmospheric science that funded us for 6 years, from 2010 to 2016, and that really funded students. And we ran 6 Arctic summer schools as part of that. So that wasn't supporting the lab per se, but it was supporting the students who were doing some of the research at the lab. And at the summer schools, we brought in Inuit and other northern representatives to come and talk to the students, so that was very enlightening for them. So, in terms of looking forward, we kind of need programs that will cover the operational expenses of working in the Arctic, right, which is different from working at a university lab down south. So that recognize the cost of transport, travel, and on-site accommodations that can fund the staff that you kind of need. So that kind of operational funding, we don't. We are always looking for programs to apply to, but many of them have different requirements, and it can be hard to meet the criteria because none of them are quite like the CIFCUS and the CCAR funding that we had in the past.
And so looking into the future, if there was a way that government could help support your work in a more stable way, how do you envision that to flow through?
Research facilities. I know there's work going on in government looking at major research facilities right now. So the very large ones, like Triumph and Snow Lab and Oceans Network. I just finished a 5-year term, on the Snow Lab board a few weeks ago, so well aware of how that works. But also able to fund smaller research facilities. Right. I mean, PEARL is just one, facility. It's a fairly large one compared to some others, but there's an organization called the Canadian Network of Northern Research Operators, which includes several dozen stations across the north. And that's really been struggling over the years. They did try to get some funding some years ago, but because it was a disparate group, not all under one university, it's kind of hard to fund that broadly. So, some kind of funding that maybe isn't major, but is going to medium-sized, or even some smaller for some small research stations too, that can provide that continuity so that you can get staff and they can build up the expertise and keep things going. So that's kind of what we're looking for. Not just PEARL, it's other stations as well that are struggling.
Other countries that are involved in research and in the Arctic, how are there any examples that you can give in terms of how other nations support research labs such as yours or other activities related to better understanding the climate in the north? Right.
So, I mean,
Short answer, please. We're down to 10 seconds.
I can't comment on details of how they're funded, but I certainly know that we partner with labs at Ny-Ålesund, Sodankila in Finland, and they have funding through European-wide and national programs that they can tap into, but obviously we don't have access to those. I don't know, but very short answer.